Alright, so for this one that everybody just got right, and I don't even know why we're working it, to be honest, I swear. We're trying to find what are we doing? Hypothesis test for what? What are we hypothesizing?
Standard deviation.
We're hypothesizing about the standard deviation. We're saying it's what?
It's either less than 2 ounces or it's equal to 2 ounces.
No, we're saying it's less than 2 ounces. That's the claim, right? The claim is that the standard deviation, mu is the new sigma, right? That the standard deviation is less than 2 ounces. This is my claim. So HO, we're going to put what? Sigma equals 2 ounces. H1 is that sigma is less than 2 ounces. How many people got to there? Just show of hands. How many of you got to there?
I had it, and I had it.
You had it, and then you changed it because somebody else over there said...
Yeah.
I didn't say nothing. She looked at my paper and changed it.
Oh, so she cheated. Okay. Just wanted to get that out there. Part B, left tail, right tail, two tail test.
Left tail.
See, you can't point when I'm looking at you. I'm like, no, don't go that way. It's a left tail test. Yes, now's a good time to pray. .01. Okay. Now, we got to go to the chi-square chart, yes? Degrees of freedom is going to be 44. Only problem is degrees of freedom don't show up at 44, so we got to get to the one closest to it. So go to 40. Now, which side are you going to be looking it up on the chart? Let's go look at the chi-square chart together. Just give me 1 second. I'll be right back with you. Hold on.
Okay.
All right, so going to the chart and looking at the chi-square chart, here's the thing you have to understand about this chart, and it's confusing at best and damn near impossible at worst. The chart chi-square is broken up into 2 pieces. There's a right side of the chart which deals with this side over here. And there's a left side of the chart which deals with this side over here. And you got to know which side of the chart you're on. Now, when you go to the chart and you look at it, how in the hell do you know which side's which? Well, basically what they don't do, which it'd be nice if they did do, was take this and cut a line right in the middle of it. And say, this is the right side, this is the left side. So over here, we're on the left side. So we have to be looking up values on this portion of the graph. Right? Now the problem is, what are we looking up? We're looking up .01. Which chart do I go to? Well, if you don't know, ask somebody. I'm just kidding. If you don't know, what are you going to do? Well, remember we talked about making this A, B, C, D, E, E, D, C, B, A? For the purpose of identification, you can identify .01 with column B and then hop over to the left side and go to the B column.
Okay.
Does that make sense?
Yes.
Okay. So then going down to the appropriate value, in our case we're doing 40. Oh, I forgot. I need to draw my letters again. There we go, right here. 22.164. Can we agree on that? I mean, is that a sure like, yeah, sure, or is that a sure like, yeah, sure?
Yeah, sure.
Yeah, sure.
Yeah, that's what I thought it was. It was like a yeah, sure.
So you don't need a right side?
Not in this case. 22.164? Okay. So we just found our critical value, yes. Now, where is 0 at? Is 0 in the middle?
No.
0 is the very beginning on the far left-hand side, right? Don't want to forget that. It's that screwed up looking one.
Are all the chi-square charts to that?
Yeah. All the chi-squares are that way. Okay. Part C, you can do it. Chi-square equals n minus 1 s squared over sigma squared. Is that right? Part D, chi-square equals 45 minus 1 over, or yeah, times 1.3 squared divided by 2 squared. I was doing it in my head real quick. I wanted to look smart, I ain't gonna lie. Alright. I want you to live on the edge. I want you to just go ahead and look at 45 minus 1. I want you to do that in your head. I want you to type in 44. Usually I don't encourage that too much. Maybe you might need to do 45 minus 1 first. Get the answer and be like, okay, yeah. 44. But just type that in. Why? When I see people do 45 minus 1, a lot of times you forget the parentheses. It gets all jacked up and then you messed up for no real good reason because you could have done it in your head anyway. 1.3 squared divided by 2 squared. $18.59. Is that what everybody got? 18.59? Okay. Now, where is the 18.59 at, though? Is it in the rejection region or the non-rejection region? It's in the what? It's in the rejection region. Remember 0, this is 18.59, right? 0 is here, 18.59 is just before 22. And by just before it, I mean like quite a bit before it, actually. Okay. So, if 18.59 is in the shaded area, it's in here, then you got to reject HO. Now, part F. If we reject HO, what do we do to the claim? Reject HO means this is false. This is true, right? So therefore, we're calling the claim true. So, no, 18.59 is the chi-square value. It's not the standard deviation. Okay? So for part F, what we're going to say, at a 0.01 level of significance, there is sufficient evidence, very good, to support the claim that sigma is less than 2. The assumptions in this case, they're on the sheet I gave you earlier. Population is